Okay, so looking at this question right here, our video is going to focus on a situation where all the sides are under radicals, which seems a little weird, but these are going to be some of your favorite problems. So let's work this out the long way, right? So this is going to be our Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So this is if you really love taking all the steps. And these are the two sides touching the right angle. So we got radical 3 squared plus radical 7 squared equals, we'll call it x squared at this point. Now, when you square a radical, they're called inverse operations. So the square cancels out the radical. So it's 3, same here, 7 equals x squared. We get 10 equals x squared. And 10 doesn't have a nice square root, so our answer is just the square root of 10. So let's write that here. Do you notice anything? Radical 3, radical 7, and the answer was radical 10. Would you like to guess what the answer to this one is? Okay, we'll do it the long way, just so we feel really good about this. So we have radical 6 squared plus radical 5 squared equals x squared. 6 plus 5, what is going on? Because now we got 11 equals x squared, and the answer is radical 11. You guys see all the work there? So let's look at this again. Radical 3, radical 7 made the hypotenuse radical 10. Radical 6, radical 5 makes the hypotenuse radical 11. This is just, because the way the Pythagorean theorem is set up, you're not really adding the numbers, but you can add the numbers under the radical to get that. Kind of a neat little trick here. So, down here, you have radical 6 and radical 13, but now we need the number that would be put together with this leg. So, hopefully without too much thinking, you realize the answer is radical 7. Okay, we don't want to go through all that. If we don't have to, we can make this a really quick problem. Radical 7, radical 6 would make radical 13. You'd be subtracting to get that. So let's go over here. Radical 21, radical 5, so that would be radical 16. So at this point you're like, what are we doing? Well, I wanted to give you a problem. Square root of 16 is 4. I kind of expect you to do that. Radical 7 cannot be broken down. The square root of 16 actually is a integer, 4. So this would be partial credit, this would be full credit. Okay, so now we know our trick. Radical 21, radical 20, and 3 would give us radical 24. If it was radical 25, we'd have a perfect one, but this can be broken down, okay? This can be broken down into radical 4 times radical 6. So once again, breaking down radical skills. So right, 4, 6 gives you 24. Why did I pick 4? It's a perfect square. Our final answer should be 2 radical 6. So once again, a lot of you will know the trick. 3 and 21 make radical 24. Some of you might have trouble getting to this step. Just one of those little extra things. Last sample problem here. I kept the 21 and the 3, but now I put the 21 on the hypotenuse and the 3 there. That means you have to subtract them. So you get radical 18. That also breaks down, but this should break down into radical 9 times radical 2. And that gives you 3 radical 2 as a final answer. Again, partial credit, full credit. So radicals, when all the numbers are under the radicals, I think we see that the general idea is pretty easy.